Hey all my family, welcome back to my channel. Today I will show you how to model, analysis, design and prepare detailed drawing for a lift core or shear wall using CSI ETABS software and Excel templates. After modeling, let's proceed to three basic points. These basic points are analysis, design and detailing. Analysis, we are going to do analysis to get a design movement and shear and to decide the thickness of the wall, and design to calculate the area of reinforcement for such analysis results, that is the design movement and design shear. And the third point is that detailing to calculate number, diameter and spacing of reinforcement. Watch this video up to the end to master structural designs of shear wall or lift core. Now it's a time for subscribe my channel to get daily update tutorials free. Thank you. Let's dive into today's tutorial. The models of the project that we are going to design looks like this. So let's go to the plan view and cancel this shear wall or lift core. After that, let's go to model it together, and we are proceeding to the analysis, the design and detailing process. So let's go to the plan view first. So go to plan, ground. Okay. After that, let's go to cancel this model by selecting all stories. Let's go to draw all this shear wall by defining first the section property. So let's go to the define menu, section property, wall sections. So I'm going to define all these wall properties, that is a wall 200 millimeter, wall 220 millimeter, wall 240 millimeter, and finally wall 260. And then I'm going to make this in one group, that is the auto select group, that is used for the software to select the appropriate wall sections. So let's go to define it. So add new property. From this property, make it auto select. Make it auto select. After that, the property type, go to select auto select list. From this the auto select list, change the color that have to use for this model. After that, property data, so go to modify or show auto select lists. So from this list, I have to select all this list, and you have to add to the auto select list, that is used to select the appropriate section of the wall by the software itself. So starting property, you can use as it is, or you can select the last wall sections. So make it okay. After defining the section property as auto select, let's proceed to draw the lift core or the shear wall. So to do this, click on quick draw wall property. From this, make sure that the property is auto select. After that, auto peer or spandrel ID, make sure that it's yes. After that, simply you can draw your shear wall like this by clicking on the green lines. After that, go to the basement floor. So on the basement floor, make sure that it's a one story. After that, it's closed at the basement. After this, let's go to draw the opening towards this direction. So to do this, let's draw a reference grid. So to draw a reference grid, I have to draw this beam around this. So I have to select and replicate towards this x direction, that is towards the positive x direction, that is 0.5 meter toward the x direction, and negative 0.05 towards the negative x direction. Select the joint around this. After that, go to the edit menu, add a grid at this point, so parallel to a y direction. Make it okay. So I have to get these grid lines. After that, you have to cancel the reference point. So go to the next story, that is a ground story. After that, go to the quick draw wall option. After that, you can select or you can draw like this. Let's go to draw the spandrel, that is the part of the wall that is above the opening. So to do this, let's go to check the wall, or check the opening dimension, that is 2100 millimeter. Go to the draw menu, draw joint object. So towards the Z direction, or the elevation, how to make it 2100 millimeter. After that, click on this joint. So I have to get this joint. After getting this joint, that is at the bottom of the spandrel, I have to make it all story. After that, using this slab drawing menu, you have to draw all your spandrels. After that, you have to assign a spear and a spandrel. This is because without assigning a spear and spandrel, the software considers this as a vertical slab. So I have to make sure that assigning spear and spandrel to make it 3D. The lift score or the wall looks like this. So go to the plan view, that is at the base. After that, selecting all these joints, go to the assign menu, that is joint, restraint. I have to make it that fixed. After that, make it okay. So go to the 3D view. So select all these wall properties. After that, go to the elevation, that is elevation 31. So I have to deselect all these spandrels. How to deselect all these spandrels. After that, go to the assign shell. After that, go to the pier level. So I have to assign as pier 1. So after this, select these spandrels and assign as a spandrel. Go to the assign menu, shell, a spandrel level as S1. So make it okay. After assigning all the spandrel and the pier, let's proceed to the next point. It's better to design these parts. So let's make or let's change it to axis or elevation geometry. So you can design the shear wall within a certain group. But in our case, let's go to a design from the base to the ground. After that, you can design the other part using this design procedure. So to do this, let's select the joint at the ground. So the joint at the ground is level 53. So using this, let's go to the design menu. From the design menu, let's set a lateral displacement target. From this, let's go to add one property. So this property is earthquake in its right direction. So the story, that is make it ground. So from this, the joint level, as I showed it before, the joint level is joint 53. So I have to insert it. After that, the maximum displacement, let's calculate it on Excel. So the maximum displacement, so make it 5%, that is 0.005 times the height of the wall. So the total elevation from the base to the ground is 6.4 meters. So using this data, let's go to check the displacement. So make it 640 centimeter or 6,400 millimeter. So the total displacement is 32 millimeter. So I will assign this data. So go to the design menu, set lateral displacement. So from this, make it 32 as maximum displacement. After that, add it. So let's go to make it earthquake in its left direction. So this is ground. After that, the joint level, I have to make it joint 53. So its maximum displacement is 32. And the next is that earthquake in y right direction. So I have to insert all this data in a similar way for both the lateral loads. So make it 32. After that, this must be way to the left direction. Make it ground. Wind in X direction. So make it ground. This is used to design or select the thickness. Using this data, the software itself design or select the thickness from the provided auto select thicknesses. Make it ground. It's 53. That is the joint level. Make it okay. After this, let's go to select this shear wall that we are going to design. After that, go to the design menu. Go to shear wall design. So view or revise preferences here. So in here I have to use arrow code. So the rebar material for both shear and vertical reinforcement, that is 500. That is good. After that, the ductility type, it's good to use a medium ductility class. After that, make it okay. So after selecting all these shear walls, that is from the base to the ground, let's go to the design menu again. Shear wall design. After that, I have to assign the pier section. From this, we have three choices. That is a simplified C and T design. That is for designs of compression and tension around the boundary or around the edge, and uniform reinforcement. This is used to design all the shear wall within a uniform reinforcement type, and general reinforcing. You have to use general reinforcing when you are going to design shear wall with opens or within a user defined setting. After that, it's better to use a uniform reinforcing in our case. So material type, I have to use a C30, and the other data, I have to make reinforcement to be designed, and I have to update it later. That is the spacing and the other data, but the clear cover must be 25. That is good. After that, the bar size and spacing is designed further. So make it okay. After this, I have to select all this wall to design only these walls. So go to the design menu, shear wall design. Have to select a load combination. So all the load combination is under a design combination menu. So make it okay. After that, go to run the analysis. After the analysis, let's go to check the displacement. So go to the display menu, deformed shape. So using the horizontal loads, make it okay. The maximum displacement is 3.481 around this direction, so it's a minimum. So using this, let's go to check the thickness. That is the software how to select by itself. So to check it for the undeformed shape. After that, let's go to the object assessment. After that, make it section. So the software select well 200. So this is the minimum wall section that we're going to define in the auto select menu. After that, let's go to the design. So let's select all these two walls only. This is because we're going to design up to base to the ground in our case. After that, you can design by yourself the other part of the wall. So go to the design menu, shear wall design, start design and check. From this, the other are not applicable. This is because we are not going to design all these parts. rather than designing from the base to the ground. So the vertical reinforcement to the base up to the ground is like this. That is, I will take the maximum from this. But before this, let's go to the drawing and show how we are going to put, or how we are going to detail in AutoCAD. So the vertical reinforcement is like this. That is towards the vertical direction. And the horizontal reinforcement, that is the shear reinforcement, is provided like this. So using all this principle, let's go to select the diameter of bar and the center spacing using error code standard. So let's go to the ETABS software. After that, let's go to select the maximum reinforcement as from the base to the ground. That may be the top or the bottom reinforcement. So from here we have 50,580. From here it's a decrease, that is about so the maximum reinforcement area, that is AS, is 15,580. And go to the design menu again, shear wall design. So go to the design info. Before this, let's go to identify all shear failures here. So there is no any failure around this. Let's go to the design menu again, shear wall design. So design information. After that, let's go to select a shear reinforcement. So the maximum shear reinforcement is around here, that is 31.64 area of shear reinforcement. So using all this data, let's go to the prepared Excel sheets. After that, using all this prepared Excel sheet, we are going to design for the vertical reinforcement and the horizontal reinforcement, that is the shear reinforcement. So let's go to design first the vertical reinforcement. 50,580 total area of reinforcement. So required vertical reinforcement from ETABS 50,580 in one face. So to make it one face, you have to make it divided into two. The thickness of the wall from ETABS output is 200 millimeter thickness, and the height of the wall is 640 centimeter, that is 6,400 millimeter, and the length of the wall is 250. That is good. After that, the required reinforcement. So I think it's clear to you. To calculate the one face reinforcement, you have to divide it into two. After that, you have to only select diameter of bar that you have to use. So in our case, it's better to use diameter of 20. I will check it, and after that you can change it the reinforcement. So the cross section area for diameter of 20 is calculated as this, that is pi square over 4. So the number of bar, so the software itself calculates the number of bar, that is area of reinforcement divided by the cross section area of the bar for 20. So I have to get 24.7, that is 25. Required spacing in millimeter. So the required spacing in millimeter is calculated as the total length, that is 250 divided by total number minus 1. So you can get this spacing. After that, the provided spacing, you must check the provided spacing, or within European norm of standard, minimum of 8 times diameter of bar, that is 8 times 20, that is 160, 100 millimeter. So from this data, you can select 100 millimeter. So from this, you can take the minimum of this, this and this. After that, you have select 100 millimeter provided spacing. After that, I have to check with the minimum still ratio, that is rho. So rho from this is 0.002, that is 2%, that European norm of standard recommends. After that, the actual still ratio. So the actual still ratio is calculated as cross-section area of reinforcement times the provided number of reinforcement divided by that of the length times the width. So you can get the actual still ratio. So the actual still ratio must be greater than the minimum 1. So using this, you can conclude that diameter of TONI at 110 centimeter spacing is provided for this shear wall, that is starting from the base to the ground. Area of reinforcement that we have get for the maximum shear. So change it to pure shear reinforcement. 1231.64, that is 1232. So the required shear reinforcement in ETABS for 2 legs, that is for both sides, 1232. So the diameter of bar used, make it 10. After that, the cross-section area of bar for this diameter of 10 is like this. The required spacing, you can calculate the required spacing as that is 2 legs. So you have to use 2 times the cross-section area of the bar, that is AS, times 1000, that is 1 meter width, divided by area of reinforcement, that is AS. After that, you can get this value. So from this, you have to provide spacing as 100 TONI. So using this value, after that is the maximum spacing. You have to compare it with 3 times the thickness. That means 3 times TONI. The minimum of 3 times TONI, 3000 millimeter. So you have to compare all this. After that, provided spacing is 100 TONI. That is actually practical. So using all this data, the maximum spacing in millimeter, that is minimum of 3 times the thickness, that is 3 times 200, this is 600, 300. The minimum value is 300. So if you compare with the provided spacing to the maximum spacing, after that you have to check the reinforcement that we have to provide. The minimum reinforcement, that is 400. You can get it as rho times the width times 1000, that is my 1 meter width. So the actual reinforcement, you can calculate using this formula. So the actual reinforcement is greater than the minimum reinforcement. So using all this data, you can conclude that you have to use diameter of 10 at 100 shear wall spacing like this. So you can design the shear wall like this. These were the most important part regarding to a model analysis and designs of a shear wall or a lift core. Thank you for watching. See you in the next important tutorial. Goodbye.